Right, looking good. All right, good on my end here. I close these windows, they're distracting. I'm not a professional video streamer, so just know that when you watch these back. Hopefully this works. And super dark in that room, so I'm not sure how this camera is going to pick it up until my lights come on. They're all automatic. So looks like it's just us tonight. That's fine. So what I wanted to kind of go over is VFDs, and we'll break it down to the basics. And if you can understand the basics of how a drive works, you could fix them. I mean, I'm not going to go into programming each one. The programming, for the most part, from what I found, when you go through the menu, and basically all you do is you tell it what horsepower, the voltage, the speed, and the amperage of the motor, and everything else is pretty well set up. You might have to change, what you want the relay outputs to do. Remember, these drives have usually 2 or 3 relay outputs that you can program them to be whatever you want, but they come pre-programmed already to, you'd have to look on it, but it's usually a fault, a running, and a ready, I believe, is the 3 that come. But basically, the relays we're looking for is the fault, and usually the ready or the running, but primarily the fault. We want to know when the drive faults out, and that we would use that relay as a fault relay. So basically, they'll have a relays. Those relays are basically like the same relays that you would find on the ROs, on the controllers that we use. It's just a switch, usually has a common, normally open and normally closed, so you can wire it however you need to. And typically those relays will go out to a DI point. We'll just call it a DI point on the controller, so the controller knows it's faulted. That's kind of what we're looking for.
I got a question. Is you say the relays are the RO points, right?
So I'm just talking about right now on the drive itself. Each of those drives have. I'm just going to kind of describe what each drive has. As far as the programming, I'm not going to go over that. So the relays, there are relays on each drive. Just the same thing as a relay on each that we use. It's just a computerized relay that switches between normally open and normally closed. We use those for the faults usually, and the ready command that tells the controller, on a DI. So it's just communications. They also have an analog input, the same as like what we use on the controllers, and it's that analog input is basically what it allows you to send it a signal, a 0 to 10 volt signal, and that tells it how fast to run. And these things usually come in when you set up the drive from brand new, as that's the basic stuff. That's basically what it comes with. It is changeable in the software. So if you ever do need to change it for whatever reason, but once they're programmed, they're programmed. It shouldn't need any changes. And I'll go over all these on the whiteboard, so we can kind of get a better idea of what it's doing. So it has a relay out, an analog in, and a digital in. It also has an analog out, but we typically don't use that. So the three we use: relay output, analog input, and digital input. The same thing as what you would use on the controller. It basically it gives us a way to communicate with that drive back and forth without having it connected to a mod bus or any other of the other types, backnets and RS-45. So we don't have to depend on that. We can depend on the signals that we send it through those three types of inputs and outputs. It's doing the same thing as like a controller. It's gathering data and sending data out through those relay outputs, sending out the data. It's getting data in through the analog in and the digital input. Digital input is what we use to tell the drive, go ahead and run. It's a run command is what I've always called it. I'm sure it's called a million different things, but for this lesson here, we're just going to call it a run command. So the run command is the signal from, we're going to say from a relay output from the controller. In reality, it could come from different areas. I like to see it coming from a side switch, and I'll draw that up on the whiteboard. And I'll tell you why I like to see it coming from a side switch. I like to see it coming from a side switch from the contactor on the drive output, and I'll show you why. So with that being said, I will give me a chance to walk over here to the other side, and I will start drawing it up on the board. Let me know if audio, I can't see my screens from the whiteboard over here. As soon as I set up my office, I'm thinking about moving my whole setup into one of my bigger rooms and set up an office. Then I'll be able to see everything. I'll put like a monitor up high or something. All right, who's our latecomers? Oh, Francisco. Oh, welcome, Francisco.
Oh, thank you.
By the way, it's Francisco that gave the request for drives for tonight. So that's why we're going over it. And if right on here, make sure it's working because it's super dark in here. Let me see if it's coming up. It's pretty dark. Put on some lights. Just made a big fuck on it. Just made it big reflection. I think we'll be able to see this. Hopefully. Okay, so What does a drive do? I guess we better answer that question first. A drive changes the voltage and the hertz equally. I guess analytically would be the word. And when you change the voltage and the hertz, you'll change the RPM of the motor. I'm not a specialist in that field, electronics specialist, but I can put it to you this way. The easiest way to put it. Let's just say you have motor number 1 here, and let's call it a 208 volt motor at 1800 RPM at 60 hertz. Right? And that's how you would order a motor, basically, right? You're looking for a 208 volt motor, 1800 RPM, 60 hertz. That'd be your typical motor. Let's say you wanted another motor, number 2, and you wanted this motor to be, let's just call it 104 volt motor, and you wanted this at 900 RPM, and it was again, you have 30 hertz. This same motor, the way it's wound, these motors are wound from the factory to work with these numbers. This motor, the specs and the way it's wound, will work with those same specs. It's the same motor. Okay, and see what we've done? We've changed, we've gone half the voltage, half the RPMs, and half of the hertz. So what this guy here, so basically, let's just say this would be 100%, and this is 50%. But what you need to know is that the motor is the same. So if you were to call the motor manufacturer and tell them, you say oddly enough, I have a 104 volt 3-phase system, then it's 30 hertz, and I want a 900 RPM motor. They would sell you this motor. It's the same motor. And everywhere in between, it's the same. So as you reduce the hertz and the volts analytically, your RPMs will reduce up and down. Okay, does that make sense to everybody? That's what it's doing. That's all it's doing. There's no more magic in there. All it's doing is changing the voltage and the hertz. That's it. Now, yeah, it's awesome stuff going about and doing it in there, and it's obviously way more than I would be able to figure out how to make that work. But the computer geniuses and the electrical engineers have figured it out, and that is what we get. That's how it works. So that's why that same motor, and it's not coming up very well, is it? Turn on more light. We just have to deal with. We're gonna have to deal with that glare. There it goes. Okay, so I was drawing it. Probably you didn't see any of it. But that is there any questions on that? Because that's important. That's our step 1. Knowing this is half the battle. I wish I could see my screen right now.
We can see everything.
You can see everything? So it's a lot better with the lights on, right? It's got that stupid glare in the background.
Yeah, we can see it go down.
Okay, so this will work all the way down to 0 volts and 0 hertz. And as you bring them up evenly until you get to the 208 and the 60, that'll be full speed. And then 0 volt at 0 hertz is 0 RPM. Okay, it's pretty simple process. This would be 0%. Any questions on that? That's what's going on inside the drive. I'm not qualified to tell you how it's doing it for the most part. I will tell you basically how it's doing that, and we're gonna do that next. There's some good information coming up here, so pay attention.
Hey, Mark, quick question.
Yeah.
Hey, so the motor has to be VFD compatible, right? You can't just put a regular random motor.
Now, no. So we did have, when VFDs first came out, I was pretty young in the trade. They've been out for a long time, but they were gigantic monsters. I mean, you know, like you got a 480 drive now that'll do a 20 horse, and it's like this big now. This thing used to be from here to the floor. It used to be like 5 feet tall. Costs like $18,000. They've come a long ways. But I got a little off topic there. What happened is we were finding in the lower speeds, the motors were like burning out. Well, what it turns out is the cooling fans on those motors is turning a lot slower. So it gets a lot less cooling. So motors nowadays, especially VFD rated motors, have a cooling fan that will keep air blowing across it even at the slower speeds. So that is the reason. And even the newer motors, like you don't really want to go down much below like 8%. Because once it starts slowing down so slow, it's still generating heat. Especially like on a hot day, there's no fan blowing air across that motor. You've all felt a motor, that's got wind blowing through it, because inside it's got that plastic fan on the end that's chopping through the air and blowing air across it. That's the reason for that. So nowadays the motors are better and they have a lot more air blowing across. But as far as the motor's concerned, the windings are the same on all of these motors. This winding is the same as this winding and the same as this winding and everywhere in between. Okay, so that's important to know. That's how it's doing it inside of this VFD device. There's 3 things that you've got to know that are going on inside this device. Let's just call this one, we'll call it a 208 volt, I guess. Why not? 208 volt VFD. It's got 3 wires coming into it, right? Well, how is this working? What's going on here? I'll tell you what's going on. I can't tell you how, but I can tell you what. Inside here is a couple of transformers, basically. One transformer you have to be well aware of. It's called the DC bus. So what it does is it takes this 208 volt, 3-phase, and this is why you can remove one phase and these drives will still work. It goes down to transformer. To the 600 volt. DC bus. Okay. So this 208 volt, 3-phase or single phase, however you've set it up. All you need to have here now is 600 volts DC, plus and minus. If you take it, if the 3-phase is gone, you now have 600 volts DC, direct current. It changes it. This is physically not connected to, these wires are physically not connected. It goes to a transformer, the same type of transformer. Well, let's say the same type. It's like the transformers we use, the 24 volt transformers for control circuits on AC and whatnot. Way more, intense stuff in there, but I guess similar to the controllers, boards that we have, the 24 volt DC, you plug in the 208 volt to it, and out comes 24 volt DC to power up the boards. Well, this one here, you put in whatever their voltage is. It could be 480 if it's designed for 480. It could be 208 if it's designed for 208. I'm sure there's lots of other ones, but this is what we use: 208 and 480. This will always be 600 volts DC. That doesn't change. From here, it goes through some other magic and wizardry. I'll draw it as a transformer. And it puts out the bottom 3-phase power again, but at whatever we have told it to put out. So the 600 volts stays the same always. The 600 volts is what always powers up the bottom half to send out whatever it needs. Well, in this case, this 600 volt DC for 100% will send out 208 volts at 60 hertz. And this is going to be 60 hertz coming in. So at 100%, it's going to send out 208 volt, 60 hertz. You've actually, all you're doing now is you've generated a bunch of heat inside here to do the same thing. You're actually wasting electricity. So you've taken 208 volt, 3-phase, 60 hertz, changed it to 600 volts DC, and changed it back again to 208 volts, 60 hertz, 3-phase. That's why you'll see, and these things, especially the older ones, you only get it's limited to how much time it can work. You've only got so much runtime on, especially the older ones. Newer ones don't seem to have that big of a problem. But old school, old days, you had a limited lifetime on these things. So if it was calling for 100% for a certain amount of time, it would go into bypass. You might still see old systems already set up like that. And that's because if it's calling for 100%, take this out of the circuit, remove it, go to bypass, and conserve this. You paid $30,000 for a drive. Let's get as much money out of it as we can, as much use. Nowadays, you don't really see that too much. I'm sure it would help. But, the stupid things are so cheap now. It's like the amount of trouble and problems that we run across with the circuits and contactors and other stuff that can go wrong and cause problems and product loss. We'll just buy another drive. They're $1,000 now. They last for decades now. 10 years probably. I don't know. They keep lasting and lasting. What really kills them, I guess, is probably the heat. The hot motor rooms, in the middle of July. It's not great for them. Up on a roof with the sun beating down onto a bypass panel, that's not great for them. But that's what's going on. Let's just say let's draw on here our AI. Remember what I told you? We have a DI, which goes out to a switch. an AI, which goes out to a board, which is basically an analog input this way. So this is our AI here. This on this side would be our AO. This side would be a switch. I'm going to tell you why I don't call it. It can be a relay output, but I'm going to tell you why I call it a switch. And then down here in the lower area, we'll have an RO. Goes out usually to a DI. And we use it for our fault signal.
Hey, so that digital switch is for it's on the panel, right? The one that says bypass or inverter?
That will be hooked. Well, no, not necessarily. This digital input is our run command.
Oh, got it. Okay.
That's our run command. When this switch closes, it tells the drive, you're okay to run. Then it waits for a signal how fast to run. I'm kind of a fan of having a 0% at a zero volts to 100%, but for the last decade or so, we had it reversed unless you're working on a Trillium, and those were set up. 0 volts means 100%. It's a good fail-safe. Why we don't use it on everything, I don't know. I just know that it's available and we don't use it. But anyhow.
Hey, Mark, I got a question. Yeah. Sorry about that. How would you bypass that drive with all those switches on?
How would you bypass it if there's a bypass panel, or you just want it to run?
You just want it to run 100%. Let's say I get to a call, condensers are down, and the drive is saying that it's running at 100%, but it's not doing anything, right? So what would you do next? Would you connect the main phases?
No.
And that's it, or how would you?
So if you get there and the controller is saying that it needs 100% fans, but the drive is putting out nothing, you would check it, obviously, to check out it's actually putting out nothing, because it could be putting out full voltage, and way over here in the corner, you've got an overload. And that could be open. So don't get fooled just because it says that it's running. It may be running. You might have where the wires come out here. Let's tie them into here. Where they come out, you've got an overload relay typically. Those may be open. So there's all kinds of scenarios with what you said. What I would mainly do in your scenario, if I came up and I saw the fans are not running, but the drive you see, it says 60 hertz. I would look up in the corner first to say if it says auto remote running or auto remote standby. If it's in auto remote standby, it means that DI has not closed yet. And I've seen that before, but typically if it's saying 60, it's wanting 60, but it hasn't gotten the okay.
So what board?
Go ahead.
I got a quick question. So what board tells it what to do? Is that an analog input that tells the board to run?
We'll get to that.
About the 1 to 10 DC volts.
We'll get to that right now.
Oh, okay.
Let me erase this. I need more room. So we've all got this pretty well, right? So what it's doing, the motors are the same. So I can erase this. I need more room.
Hey, you did mention that it's better for us to get a brand new VFD if the older one is just tripping.
If you've got an old one, man, get it out of there.
Perfect. Okay, so over at 2002, the HVAC, the air handler, it's an antique, so we might as well replace that.
Like an old Danfoss one or something?
Yes, sir. Old
Danfoss. Like with the silver metal box?
Yes, sir.
Yeah. Just get rid of it.
Will do, sir.
Get a new one. Not only that, we can capitalize that kind of stuff. So let me delete this line here. Here's where I like to hook up this run command. Coming out of this drive, these wires will always go up and go into a contactor. And the contactor's there so it can bypass. Let's put the VFD. Let's put a bypass contactor in here too. And those just connected right there. We'll call this bypass. It's a contactor. This bypass contactor would get the wires, get the power from right up here. So it's the same. Well, this is what you're looking at. It's how it's wired internally in the bypass panel. I like to see this DI right there on a side switch right there.
So the DI is AC volts, or I'm assuming.
So this cannot get the run command until this contactor is pulled in. The reason I like that, and this contactor is usually controlled by, the controller telling it to it's go ahead and run. It always tells this contactor to pull in. Well, with that, I like to then give it the run command. A lot of times you'll see it on a cube relay up here, where this DI hooks onto the cube relay and the VFD contactor hooks into the same cube relay. Yeah, it does the same thing. But if this contactor doesn't pull in for some reason, let's just say it's jamming up for whatever reason, this drive is going to ramp up. It's going to ramp up full power, but it hasn't gotten past here. Let's just say that, somebody bangs on the panel or something, the contactor flops in. This thing is going to get full current as this closes, and it's not good for the drive, and it'll overcurrent. It'll fault out on overcurrent. So I like to see this run command coming off this contactor. If this contactor is pulled in, it tells the drive, you're good to go. Run, and it'll run at whatever the AI is, from this board here. Let's call this a board. That's a CPC board, AI, DI. But we're just going to use the AO part and the DI part. Usually you'll see them on different places, but if it's a control, you see the old ones, that would be an RTU card, because it's got the AO, it's got the DIs, and it's got the relay output, which the relay output is what would control this. So you use two relay outputs, one for bypass, one for drive run.
Question mark. On the VFD, do you need a login to override it to manual?
Shouldn't.
You shouldn't, right? Okay,
No.
So the one that I worked on is bad then, because I'm not even able to manually put a manual on or give it a percentage or raise or lower the percentage of that.
That's not
Modern.
Right. Somebody screwed you. Hopefully they wrote the code somewhere, because I wouldn't know what it is. Now, the newer drives that are all in one, bypass and run panel, it's all one built-in drive. So this doesn't apply. It's there, but it works differently. It has other boards in there. I don't, this is the new way to go. I guess I got to get used to them. All these contactors are 24 volt DC. It comes off of the board. Well, it comes off the other board that's tied in with the drive. I'm not even real familiar with those because I have not been in the field since they've come out. So I'm going to have to get up on those. We've got a lot of those. That's the ones where you tell it you want it to bypass and you have to hold the button and the bar goes across, saying it's going to go into bypass in 10 seconds or whatever, and then it bypasses. That's the ones that are built in typically into one big unit. It still has a VFD contactor and a bypass contactor, and that also has a reset contactor built in, which would be right here. Basically, it kills, it turns off this, and turns this off. And then it cycles power to this, turns the power back on, and then gives it a reset command into another DI. So there's several DIs on these things you can wire in. But for this class here, this is more basic. How is it going? What's going on inside and bypass panel? Let's not get into the newer ones. They work on a lot different systems. Let's learn this first before we get into the other stuff, because I'm not as familiar with that either. But I know they're out there. I know that these contactors are all 24 volt DC contactors. It gets the power from the drive, the board that comes off of the drive. It's different, but it's high tech stuff. It's here to stay. It's not going anywhere, so we better get used to it. That's all I can say. Okay, so this is basically what we've got in a nutshell. Three-phase comes in, DC bus here, sends out whatever voltage it calls for from this analog output to this analog input if this DI is closed. If there's a fault, this relay closes, tells this DI I faulted out, the controller puts it into bypass. Opens this one up, closes that one. That's the sequence of events on it. Remember this overload relay down here, especially on these newer ones I've found, they're way deep inside there. Just be careful, shut off all the power to it because they are deep in there. They're hidden up inside. Double check that these are set with a high enough amperage on them, because I found too many times that these things aren't set high enough and the overload relay's cutting out. And, we've got literally guys coming in and taking the power and connecting them together when all it was that overload relay needed to be reset with a little push button here. A little reset button.
So question, where do you think that overload relay is at? Like in the junction box, in the little compartment?
In the one I'm drawing here, it's always so this is like one of the big panels. The ones that haven't been phased out yet, they're like 3 feet wide by 3 feet tall and a foot thick or whatever. It's always down here in the corner in the right, and it's obvious it's there. The newer ones, the big drives with the bypass already built in, where the drive is up in this area up in here, but down here you'll see it's covered with the switches, the on-off switches, which right down here. It's way back up in here. If you got to shine a flashlight up in there though, but it's up in there. So be careful. It's there. Got a reset button. I can't remember if it's here. I think it's more down here, but there's a button and there's also a dial. Double check that dial is up high enough to deal with whatever amperage that motor is drawing. If that motor is going to draw 20 amps and this thing's set for 10, it's going to trip. You're not going to know if you don't even know it's there. So these are the ones where I believe it's got a door that swings open, or I think the door swings open, but it's covered. It's super deep and there's a bunch of stuff here in front of it. And way back up inside there, that overload relay's up in there. Got to use a flashlight or you never see it. Don't try to stick your hand in there either, because there's a lot of high voltage wires right there. Shut the power off, let it drain down, let it turn off, and then, double check to make sure. You'll hear it click. You'll feel it with your finger. It'll click if it's tripped. And if it is tripped, then double check, make sure the voltage knob is turned up high enough, or the amperage draw knob, to set it high enough. That gets a lot of guys right there. The overload relay. If it opens, it's not going to send voltage out. It's going to, on most of these, it's going to kill the control power. The control power is ran through it, and it's going to kill power to everything. So you're going to be like scratching your head, like, what? Why don't I have control power? It's going to open it, and it'll shut everything off. So be aware of those. Hang on a second.
How's it going, Mark? Haven't talked to you for a while. I have a question for you, Mark.
I think he went to the restroom real quick.
Oh, all right. Never mind.
What's up there, Ray?
I'm too old
How's
for
it
that.
going?
Sorry about that. Had to use the restroom. All right. Any questions so far on this? I don't know if we're going to go much farther than this for today.
Mark, I have a
Yeah.
question for you.
Yeah.
So I had a scenario at a store in LA. So the drive blew up because there was a short on the lines on the conduit, which took out the motor to a furnace. So I had new lines ran, and I had pretty much had to bypass the VFD to that guy.
Yeah. So you just bypass it. Take these 3 wires, move them down
Yep.
here, and that's that.
Got that guy going. The blower motor came on, but the furnace didn't come on. It was telling me that there was a proof fan heat on it, so it was locking out. So when I went to this is a E2 controller, so I went to the analog inputs, and where it said fan heat, I manualed it on, and the furnace kicked on. The RO closed, gave me voltage, and the furnace kicked back on, no problems. But when I turned auxiliary heat on, the RO should close, give a weight across, and I wasn't getting that.
So, is that the one Aaron called me on the other day?
Yeah.
Oh, so that one turns out it's the programming. It was really wacky, and it had a digital sensor controller that actually controlled the heater, and it had a proof. It was made so that if the fan, it was way stupid. It had a fault on it, and it also had the fan proof on it. So,
right. So the
Yeah.
fan proof is on the VFD itself?
no, not in that case. It was just a fan proof going to a sensor control. The actual physical fan proof would be on the duct.
Got it.
And I don't know why it and it also had a fault on the drive. So if you had turned the drive off, it would have opened up one of those digital sensor controls and nothing would come on.
Right.
But since the fault was gone, all that we had to do, and I didn't password for it. All that had to be override to off, or to I think it was on, and then everything would come on.
So when I manualed it on the DI, the set reading 135 degrees that I was pushing out.
Well, that's
So-
something all different altogether, probably.
Right. Yeah. Yeah. So to me, it was kind of weird altogether.
Yeah. It looks like somebody tried to get real cute and complicated with the controls, so that the furnaces would turn off if the drive faulted, the furnaces would turn off if the filter switch was off, and the furnaces would turn off if the fan proof wasn't coming on. They had so many things going to it just to control the furnaces. I mean, if it was me, if I had a high enough password that day, I would have yanked it all out and put the furnaces back on the controller, back onto the task that did the air handler. Because that's what they did. They removed it. I could show you the programming one of these days. It's probably too late to do that now, but I would just take those ROs. They took the ROs off of the task, moved them to a digital sensor task.
Yes.
And then took the output from that task and moved it to the digital sensor task. So that would control, if it called for heat, and it was a and task. If it called for heat and there was no fault and the filter switch was good and the fan proof was good, it would allow the heat to come on.
Yeah.
One of those was not making, and I'm guessing from the drive because you had powered it down.
It out. It smoked it when it caused a short.
Yeah. Oh yeah.
It smoked it. So
yeah.
Right on. That sucks.
Hey, Mark, I got a question for you. What do you mean about high-end password?
I didn't have the password I used wasn't high level enough. I don't know why.
So how would we get that high-end password? Or do we have to call it DAMFOS?
They're not going to give you, what I found out later was that the password that I was using would work on the controller, but you got to remember that I have a different, it looks totally different on my end. What you guys see looks, if you saw what I'm looking at, you'd be like, what the hell is that? And it's kind of weird because I've always used this program. And so when I look at, if I was on an E2 controller, I would look like a dummy. I'd be scratching my head like, what do I do next? I wouldn't even know what buttons to push. I'm not even lying. I'm not kidding. I wouldn't know what to do. It looks completely different. And I just, for the last 10, 15 years, I've been using this software. It's different.
Okay.
So I can get through an RMCC easily enough.
And question, are we ever gonna have real live training where we learn about the new VFDs? You know how you mentioned on the picture, on the diagram?
So so the easiest way to do that kind of training would be go to a store that has one in operation. We could all be, have a group meet at a store and go through it at a store where it's already running. Because I don't know how we would do it in a classroom setting. How do we make it run? How would we do it? We've got 530 training centers out there. Each store is a training center.
I'm down. Let me know.
Yeah, me too.
Yeah.
I'm down.
Yeah. So let's plan a field trip. Especially here when it's cooler out and we can afford to have some guys out to do that. We can meet at a store.
Yeah, because if those are gonna come out for the brand new VFDs, I would like to experience that. The newer ones. And yeah, I mean the old stuff is going obsolete, and the new stuff is coming out now.
It is, yeah. But what I went through on this, the same everything applies. It just uses different voltages now and different ways of doing exactly what I showed. Nothing's changed. You still have the VFD contactor. You have the bypass contactor. It uses an AI, AO, DI, and RO. The drives work the same way. They have a DC bus. Everything I put on there, nothing changes. The only thing that changes is they're more compact, and the contactors are different. They have different boards on there. And it's a little more computerized, but
That's why.
it's still the same components are there. All right, next question. I got Alejandro.
Yeah, I had a quick question. Is the I'm assuming that like whatever DC input that the VFD receives, like if it's like 6 volts, is that like half of the hertz?
Let me go back to the whiteboard because I think I hear what you're saying, but I don't know exactly. So you're talking about the control voltage to tell it to run, or the main lines. I mean,
The control.
so the coming out of the computer.
Yeah, coming out of the computer, the one going to the VFD.
I think I went right over that, and I meant to go over that. And I started talking about it, how I would rather see a 0 volt being 100% and a 10 volt being a 0%. So we have a 0 to 10 volt DC coming out of the analog output. Most of these bigger drives that we have out there, 0 is 0%, 10 is 100%. I'm not a huge fan of that, because if you burn up this board, typically it's set up always on the same board. So if that board does burn out, the relays will switch back into failsafe and it'll bypass itself. That's the idea of that. But I would rather see 0 volts being 100% and 10 volts being 0. That way, if you do lose this DC volts, it's just going to drive the fans on 100% and it'll just be running. Because condensers, obviously, we would rather have them running at 100% rather than 0 in a failure situation. But the way that's physically wired to our analog output boards and our relay output to our control boards from the E2 or the Danfoss, it's supposed to all be on one board. That way, if that one board fails, yeah, you'll lose your analog out, but you will also go into fail-safe mode on that board, meaning the relays will go to normally closed, which will trigger everything to go into bypass. So in a perfect world, that works. Danfoss, though, I don't even know that they have a board that has voltage VO analog output that has relays also. I guess on an RTU board they would, which is why Comtrol, we always use an RTU, and on Emerson, we would use a multiplex board. So it's all one board. But remember, it all should come off of one board for a drive. That way it can fail safe. But yes, when you get into like the new Trillium stuff, we've got 0 volts is 100%. 10 volts is 0%. They are backwards, but those also have the drives built into every motor. So every motor has its own drive. All we do to control it is send this 0 to 10 volt DC signal out of an AO board, and that's all we do. Everything else takes care of itself.
That's all the BFD.
What's that?
That's in all the BFDs, the 0 to 10 DC volts.
That's what controls this. Yeah.
Right. Yeah.
Yeah, and anything in between. So 5 volts would be 50%, right?
Right.
And everything in between. 7.5 volts would be what, 3/4? It's analog. It's analytic.
Yeah.
So
right.
5 volt equals 50%. So if that is your question, then yes, that is how it works. Obviously, it's coming out of this AO board on the, we'll call this multi-flex. We'll just call this an E2. Because this would be the E2 sending out these signals. And then the RO be coming out here and controlling those. So you got an RO for the drive, RO for the bypass. But those control the contactors, right? Those, in perfect world, these ROs do not control the drive. When you could put an RO controlling this DI, but I like to see it, and you're going to see it a lot on everything that's from the early 2000s and 2010, up to about 5 years ago. You're going to see the side switch on the VFD contactor is what actually tells the drive to run, which is good. That's a good thing. So yeah, if you see this thing on auto remote standby, it's because this contactor's not pulled in. Why is that contactor not pulled in? That's up to you as a service tech to figure that out. Because there's a lot of scenarios, the RO didn't pull in. The RO is blown. The fuse is blown. You've lost control voltage for it. There could be multiple scenarios. I can't just tell you, look for this, because I told you 3 things to look for. Blown fuse, lost control voltage off a transformer, because this, or, if it's 208 volt, you probably won't have that. There'll probably be, line voltage off of a fuse somewhere, blown fuse on the control circuit, blown cube relay. If it's using a cube relay fell out. I mean, I could go on and on. You guys know things that could be wrong. That's why we try to let you know the different things that could. So yeah, there's a lot of different things. I wish I could have you guys in front of one of these panels, and next time you're at one of these panels, look back and you think to yourself, is that's what's there. And it's not, I mean, it looks super complicated when you walk up on one. And it is. But when you take it down piece by piece, it really isn't. It really isn't. There's not a whole lot going on. You can figure it out. I know you can. Mr. Lozano, you still got your hand up?
Oh yeah, I had a question. When you're talking about the side switches, you're talking about like an auxiliary, right?
Auxiliary, yeah. I'm old school. I call them a side switch. It's a auxiliary switch is the technical name.
So for your DI, that's not voltage, right? So you would use like Belden.
It's a Belden. That's just a Belden cable.
So you would run it to your common and then coming back to the VFD like a normally open.
On the run command, it's where you have 12, 27, and 18. You know how you see them on the Danfoss? It's got the jumper, how you have to connect all 3 of those, and you have the 2 wires. There's almost always going to be only 3 control wires coming into this drive. Run command, speed, which is going to be an AI from your AO, and a fault. That's it. There's not much more. This is all we need to know. So yeah, this will be a Belden coming up to 12, 18, and 27. Basically, it's sending out the 24 volts through the side switch, coming back to 18, and then the drive knows. It's a closure here. We call it a digital input because it is a digital input. It's a closure. It's a dry switch, but all DIs do have some voltage. You have to have voltage to know that something has happened. The computer is spitting out however low of a voltage it is, if it's spitting it out this way, it needs to see it coming back. And if it sees it coming back, at that point, it knows it's closed. If it doesn't see anything coming back, it's open. Doesn't do anything. It's open. So yes, that auxiliary switch would be that contactor pulls in because that RO tells it to run, closes that, comes back up here, tells the drive you're good to go. This analog output's putting out 5 volts. The drive says, oh yeah, you want 50%? Ramps up to 50%, which on this one here, remember we talked about it, it'd be 104 volts at 30 hertz coming out through the VFD contactor out to the motor, and it'll run half speed.
All right, got it. And your AI, I mean, the speed, that's basically from the board. That's all just calculations. You got to write it.
That's that. 0 to 10 volts coming out of the E2.
But to program the E2 on that, that's all like writing code.
The program on the E2 is telling it the board. So if it's calling for 50% on the E2, the E2 is going to tell this board to put out 5 volts. So that'd be Belden. This RO can be Belden as well. Although you're going to see it's not a lot of times, but it's usually just going to a DI. That's all it is. The RO closes, tells the board, which then tells the E2, hey, I got a closure here. We've got a problem. The drive is calling for a fault. Let's do something about it. The E2 does its calculations, opens this RO, closes this RO, which opens up this contactor and closes the bypass. And now it's a bypass.
Thank you.
Go ahead.
I said thank you.
I can get in and I can talk about phasing these things. If you guys are interested, there is only one way to phase these. I don't care if anybody tells you different, they're wrong. If anybody tells you, oh, if it's spinning backwards, coming out, you can switch these wires in here. No, you can't. I mean, yeah, you can. It will work, but it's going to short out. Only one way to phase the wires. Everything in here always has to be the same. Line 1, line 2, line 3. Line 1, line 2, line 3. Line 1, 2, 3. 1, 2, 3. Line 1, line 2, line 3. Line 1, line 2, line 3. Line 1, line 2, line 3. It all has to match. The only wires you are allowed to change are here and here. That's it. But you can phase these things. And let me tell you, so now that we know, okay, let's go to another thing. We're talking about phasing it. And I'm going to ask some questions. I'm going to ask a question here. We all know that we reverse 2 wires on 3 phase, the motor will spin the opposite way. Correct? Everybody knows that, right? Common knowledge. Let's just say this thing's calling for a drive. It's coming through here, going through the drive, coming through the VFD, going out to the motor. If I reverse 2 of these wires here, and it's running in drive, will this motor spin the opposite way?
No.
Anyone else?
Yes.
The answer is no, it will not. And here's why. Remember what I talked about. The 3 wires coming in here goes to a DC volt bus. You got a plus and a minus. If I swap 2 wires here, I still got the same DC bus, 600 volts, same plus, same minus, meaning The output is going to remain the same, regardless of what I input here. Now, if it goes into bypass, it will spin the opposite way. Meaning, you could have scenarios, especially you're putting a brand new one in, and you've lost track of your wiring. You can have a scenario where bypass runs backwards and drive runs forward. Or alternatively, you could have another scenario where the bypass runs forward and the drive runs backwards. Or alternatively, you could have a scenario where both of them run backwards. Or the best case scenario, you plug it all in and bypass and drive run the same direction. Out of the hundreds of these I put in, that has happened 0 times. 0. It's never happened. I've never gotten that lucky. I have a 1 in 4 chance, and it's never happened. I've always gotten the worst scenario. But knowing that this does not change, when I change it here, this won't change if it's running here. But if I change it here, both of these change. Knowing that information, you can do the correct swaps here where it will run properly. Let's just say, for instance, both of them, you turn it on, both of them running backwards. Simple. Swap 2 there, off it goes. It'll run correctly. Perfect, easy. That's the best case scenario. Scenario 2, this is running forward. This is running backwards. Swap 2 wires here. You're good to go. Now this will run forward and that'll remain running forwards. Scenario 3, this is running backwards. This is running forwards. Wait, I just said that, right? No. Either way. So in that scenario, you have to swap these 2 wires first, or it doesn't matter first, but I'll just say it first. Let's just say you swap these 2 wires first. This remains running backwards. Now this starts running backwards. Now you swap those 2. That's how you would phase it. It's the only way to phase it. Do not ever swap wires in here. Anywhere in here. Keep that the same. It can be done with the wires coming in and the wires going out. Okay? Everybody get that? I can go over it again if you can't, if you don't got it.
10-4.
So yeah, just keep that in your noggins for another day when you do change one and you're like, oh, fuck, it's all jacked up. It's not. It's a simple fix. Just all you got to remember, this does not change because the DC bus always remains the same. Just remember that and you'll be good to go. Everything else is simple.
I got a question mark.
Go ahead.
Does this apply to like a digital compressor?
A digital compressor. No. A digital compressor is just basically an unloader. That's it. It's an unloader that works internally. Now a compressor that's on a drive, yes. If you put a compressor on a drive, everything here is the same. Everything. Nothing changes. This is for compressors on drives, anything on a drive. A digital compressor, I love those things, by the way. They're great. But all that is an unloader. It's a weird, they call it digital, but all it's doing is turning the unloader on, off, on, off, on, off. You know, and it's not identical. Internal, the guts, how it works, I don't remember, and I don't really care. All I know is that as it's cycling, the compressor's pumping full, not pumping full. Pumping full, not, and you hear the thing going, That's all it's doing. It's full pumping, not full pumping. Full pumping, not full pumping. And they made it so that you can you can do that on and on and on without messing with the compressor. I don't think you could do that with a regular unloader, but I'm not an expert on that. Maybe you could. It's probably not good for it though. The digitals are designed for that. So digitals do not slow down. They remain full speed, and it just unloads it, then loads it, unloads it, loads it. So, but yeah, if a compressor was on a drive, yes, everything is the same. Any other questions? What did I miss? I'm sure I missed something. I'll leave this up next Wednesday. Well, 2 weeks from now, we'll pull this up. If you have any questions about this, or if I missed something, or I got something wrong, I'm not perfect. If I got something wrong, bring it up. Let's talk about it. You know, I'm not perfect. I could have gotten something wrong here. I don't see anything offhand that I did, but if I did, let's discuss it and we'll talk about it, and we'll make corrections. But I think I got everything.
I believe so too.
I just, after doing a ton of them, I learned a lot of this stuff along the way. Remember when these things came out, everybody was like scratching their head like, the hell? What is this thing? It was all voodoo to us,
That's crazy. Now we're going on like stuff like it's new school now. The old school stays old. That's insane.
One day those drives will be so small, it'll just be a little cube relay with gigantic wires going into it.
To be honest, I really do think that in 10 years from now, all the compressors are going to be run off by drives. It's really good to learn this.
Well, we tried that, and we did not succeed. The drives and compressors don't mix real good. Slowing down the compressor does weird stuff to the oil pressure, and we would always end up with oil fails, and no one could ever really figure it out. And then the digital compressors came out, and everybody scrapped the idea of drives. I mean, I guess the CO2 ones are now going off on using drives, but same shit's going to happen. Drives and compressors, as far as I'm concerned, and maybe I've just seen too much, bad stuff. Maybe we put them on the wrong systems. I don't know, but I was never a fan of it. They would always fail on oil fill, or there would always be a fault. There would always be something, and you'd go there and you'd reset it, and the thing would take off, and you're scratching your head like, what the hell? And then it'd run good for a month, and then same thing. It would mask problems, and I don't know. I wasn't a fan of them. And then, like I said, digitals came out, changed everything. Everybody went to digitals because you didn't have those problems. I mean, we had all those Whole Foods that were all ran with those drives, and it was gnarly. Everything, they're always in bypass because they're always having trouble.
But the screw compressors have drives.
Yeah, that's different. Screw compressors don't work on oil pressure. They don't have an oil pump. They depend on high pressure oil being injected into them at all times. So you can slow those down, and it doesn't matter. The thing will inject oil all the time. It's running, it's injecting oil. That's why they have those gigantic oil separators. That's why the system, when we converted that store in Dora, out of one pipe over 5 gallons out of a header of oil. How efficient is that? You're moving refrigerant and oil. It's not great, but they were efficient compressors. They're just expensive, hard to get, hard to change. And you lose one, you're just down. So yeah, they're probably great for a warehouse. You've got a warehouse that you've got a guy every day. I always talk about it like this. Like, yeah, if we had a guy walking through that machine room every day with a clipboard checking everything off, looking at gauges. Okay, that's good. Okay, that's good. The things would run forever, you know, because then they go through the checklist and like, oh shit, something's not right. Let's find out. But,
Except for the ears.
yeah, the problem we have is we get the thing running, it looks good, and you're like, okay, you walk out, shut the light off, and you don't come back until it's broken again. So for supermarkets, thumbs down for me for screws. Just too much hassle, too much oil. I mean, you got to change the oil once. You have to change the oil at least once a year. The shit's like 30 gallons of oil at $300 a gallon. Cut it out. After a while, you know, you just throw your hands up like this. It's got to go. We got to get rid of them. But yeah, they saved a lot of electricity. That's for sure. There's no pumping, no moving up and down. You guys know how the screw compressor works? I have that little demo thing.
Are we gonna get rid of Cheviot Hill screw compressors?
Eventually, but yeah, I'd love to. In fact, they're starting to go bad. You guys probably won't be able to see this thing. I got this on eBay. I don't think you see. It's a clear. This company Solar makes compressors. They're for air compressors. So they're when a company that needs like a lot of air, like factories, use screw compressors for the air compressors. And they have this little demo thing where if you watch it and you can see how it's moving and stuff. It's really cool. There's no up and down. Everything's just spinning. So the efficiency is great. And then it's not what you think. You know, you look at it, you think that the screws are compressing it, like as they go here. They're not. The screws are actually moving it away from the middle. And as it goes like this, it's pushing this way because the screws have sealed it over here. And it pushes it. It keeps spinning. It pushes it. And it has no choice but to come out the discharge line right there. So it's not actually going through where they connect. That's what I used to think. But no, it's not. I got this on eBay one day. That was the coolest thing.
Question.
Yeah.
Question. They do run backwards, correct?
Huh?
They do run backwards, right?
They can only run one direction. They will not run backwards.
Okay.
No. And if you looked at this little thing, you would see why. If you had this in your hand, you'd be able to look at it.
Switches.
So they do have a device on there that lets you know if it's running backwards. If it's running backwards, it will get higher pressure on the suction because it'll actually be pushing it the opposite way. It'll be pushing.
So they do run backwards, but it's not supposed to run backwards.
No, it's bad for them. If they run backwards for more than about 5 seconds, it'll ruin them.
Perfect.
And it's because of the way that the cuts are made. They're only designed to run one way smoothly. It will turn backwards, but the way that everything's machined, it's not designed for that. And you'll like bearings will start thrusting the wrong way.
Right.
And it's all bad. Yeah, they run backwards, you're done. But yeah, there is instances where if something happens to the phasing of the building and it does turn backwards, there is safeties that's supposed to shut them down and keep them down. You know, it's the two lines that come here and here, and the suction and the discharge. And if it ever goes higher pressure here than here, and it goes, there's a check valve on these things. So it's in between the check valve right here. So if it ever turns backwards, it's going to go lower pressure on the discharge high and be higher here. It shuts it off and trips it.
And the rotation switch. It looks like a oil fail control.
Yeah. Yep. And you got to be, be careful. Careful on those. If you're putting a new one in, you'll want to make sure they have a rotation tester you can hook up to it. I think we have one. Typically, if you hook the wires up the same, it's gonna run the same direction. So keep an eye on that. But yeah, I'm not a fan of that. I thought I heard Garrett over there.
Yeah, no, that was me. They have the anti-rotation switches. They look like an oil fail control.
Yeah. Yeah, if it trips on that, be careful. Because you don't get many seconds on those. All right. I think we've used up our time enough. So we're gonna we got a good crew here. God, where all you guys come from?
Bring out the turkey.
Dang. All right. Okay, so I did put this on YouTube here. Let me go ahead and sign off of this. How can I do this? I will stop sharing, and as soon as that stops sharing, I will stop the stream. Sorry, there's just like a super long delay. It's still broadcasting on YouTube Live. Oh, there it goes. And all right, the stream has ended.